when we talk about AI, how do we actually classify the different systems out there? Well, today we're going to look at a really powerful framework that does just that. We're going to explore the four functional types of AI, looking at their evolution from the simplest reflexes all the way to the frontiers of consciousness. So here's how we're going to break it down. First, we'll set up the whole idea of AI's functional evolution. Then we'll dive into each of the four types, one by one, from reactive machines to self-aware AI. And finally, we'll pull it all together and see what this means for the path ahead. All right, so to really get a handle on the AI systems we're all building and working with, we need a solid way to classify them. This isn't about narrow versus general AI. This is about understanding the core mechanics of how these systems think. And this functional framework gives us the perfect lens to do that. Okay, before we go any further, let's make sure we're all on the same page. At its most basic, AI is about a computer system simulating human capabilities. But as you're about to see, the way it simulates those capabilities has evolved a lot. And that evolution brings us to these four fundamental types. I want you to think of them like rungs on a ladder. Each step up is a huge leap in complexity and what the AI is capable of, starting with the most basic form of machine intelligence you can imagine. So let's start at the very bottom of that ladder with type I, reactive machines. This is the oldest, most fundamental type of AI. It's really the bedrock that everything else is built on. The defining feature here, and this is the key, is a complete lack of memory. These machines see the world only in the present. They get an input, and based on their programming, they spit out an output. That's it. The idea of learning from the past just doesn't exist for them. And the classic textbook example of a reactive machine, it's IBM's legendary chess-playing supercomputer, Deep Blue. So what made Deep Blue purely reactive? Well, it had absolutely no memory of the game's history. On any given turn, it would look at the board as it was right then, calculate all the possible future moves, and just pick the best one. It was pure reaction with zero learning from what happened before. All right, time for the next step up the ladder. Type 2, limited memory. This is where AI makes an absolutely critical jump forward, because now it can look back at the past, even if it's just for a moment. These systems can hold on to recent information, but only temporarily. They don't build a huge library of long-term memories like a human does. Instead, they use data from what just happened to decide what to do next. It's a fleeting memory, but believe me, it is a total game changer. And that's really the core difference, right? We're moving from a system that only knows right now to one that can understand what just happened a second ago. And that simple ability to include the immediate past allows for way more complex and dynamic behavior. A perfect modern example of limited memory AI that you've definitely seen is an autonomous vehicle. This capability is absolutely fundamental to how they navigate our crazy, unpredictable roads. Think about it, right? A self-driving car has to constantly track the speed of the car in front of it, where pedestrians are, what traffic lights are doing. All of that is recent, dynamic data. The memory that a car just changed lanes is vital for the next decision, but it doesn't need to be stored forever. The system just combines that brief, dynamic memory with its static, pre-programmed memory, like maps, to drive safely. Now we're getting to the frontier of AI development today. Type 3. Or what's known as theory of mind AI. This is where machines start to understand not just what we're doing, but maybe even why we're doing it. This is a massive leap in sophistication. A true theory of mind AI wouldn't just see a person frowning. It would start to guess that the frown might mean they're disappointed or confused, and that feeling will probably affect what they do next. It's all about grasping intent and internal states, which is a profoundly difficult problem to solve. We're actually seeing the earliest hints of this in some of today's most advanced language models. Their amazing ability to follow the context of a conversation is a small step in this direction. But, and this is a really important but, we are not there yet, not even close. While tools like ChatGPT are incredible, they're simulating understanding, not truly possessing it. They're just masters of pattern matching. They don't genuinely get human beliefs or emotions. They're really just very, very early prototypes on a long road. And that brings us to the final, and for now, a purely theoretical, stage. Type 4, self-aware AI. This is still the stuff of science fiction, but it represents what might just be the ultimate evolution of machine intelligence. A self-aware AI wouldn't just understand that you are happy. It would have some concept of what it means for itself to be happy. This implies real consciousness, a sense of self, its own internal thoughts and feelings. So, with all that in mind, what are some of the groundbreaking real-world examples of this tech that we can point to today? The answer is none. This type of AI simply does not exist. While the field is moving incredibly fast, creating a truly conscious machine is still a monumental challenge that's likely a long, long way off. And this is where this whole functional framework connects to the bigger picture. A true self-aware AI, one that has consciousness, its own beliefs, maybe even desires, that would almost certainly be a form of artificial superintelligence, or ASI, an intelligence that could far surpass our own. So, to recap the whole evolutionary path, we started with reactive machines that only see the present. Then we evolved to limited memory systems that use the recent past. The frontier we're working on right now is theory of mind AI, which tries to understand intent, and a hypothetical end goal is self-aware AI with true consciousness. For any of us working in this space, this framework is a vital tool for classifying systems and really understanding their current limits and future potential. So understanding this progression gives us a powerful map of where AI has been and where it's probably going. But it also leaves us with the biggest question of all. As we keep climbing this ladder of intelligence, how do we make sure we guide this evolution ethically and safely? What does it really mean to build machines that don't just compute, but actually comprehend? Thanks for joining me.